graphical analysis part on their paper itself, okay? It's okay if you didn't get done. I just want to make sure we're not wasting a lot of time on this, because this is something that you actually can find out more than you think from a graph. Right, my copy's a little fuzzy, but I want to hear from everybody if I can, if possible. So everybody's writing down the answers for question 1. Here we go.
Can we go up and down a bit?
I only put the top part. Everybody else has the pictures.
Okay.
So.
For part A, determining the rate law, or well, first you have to determine the order. And if you look at the graphs, the most linear, the one that has the highest R squared is the bottom one, which is 1 over concentration versus time.
Okay, so put a star next to that graph. This has already been done for you versus you putting it in stat plot L1, L2, L3, L4. This has been done for you on this graph.
Which makes it second order.
So then somebody else tell me the rate law. If we know it's second order, what is the rate law?
That'll be 1 over C4H6.
So we're saying you're telling the integrated rate law? Okay, I can do that. Give me just a second. Say it out loud.
It's the 1 over C4H6
equals. Somebody else add to it. Okay, that's the integrated rate law. What is the rate law?
Critical rate equals
K
concentration of CA. Yeah, okay. Squared.
So
C4H6.
right, K times C2H6 squared. And then I want everybody to make sure, like, we know this is the differential rate law, and you guys just told me 1 over concentration is equal to positive KT plus 1 over concentration initial. And these are the reactant there.
Mm-hmm.
If this is in y equals mx plus b, yes, y equals mx plus b, what do you automatically know about the second question? K, automatically, without a doubt. Everybody, what's K? The slope, which is what? 0.0142. K is 0.0142. You see that took about 3 seconds? If you understand the slope is the K. And that's why I formatted all of our integrated rate laws as best I could to be a linear regression, y equals mx plus b. So you see that, like, the y-intercept is 1 over the concentration. The slope is K. The time is the x-axis. And then, I'm sorry, that's y. This is the y-intercept is our initial. So basically, if you know slope, which is a on y equals mx plus b ln reg after doing stat plot, you know K. But what are the units? That's the part that doesn't tell you.
1 over molar squared.
Ooh, molar seconds, because whenever you do this molarity squared to get rate as molar per second, then the K has to cancel out one of the molarities, and that's why it's per molar second versus anything more. Okay? 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 Part C, how would you find the half-life? If it's not first order, you're supposed to calculate half-life at initial. So did you guys get to half-life at all?
No.
Okay, who's got that half-life formula memorized? Don't look at it. For a second order.
1/2.
Good start.
1 over 2 K.
Making stuff up, right?
Ln2.
1 over K.
So we're making stuff up right now? Is that what's happening?
Yeah.
All right, go sit down.
I have a general idea.
But if you don't remember it, can't you find it? Can't you just put it in the formula and derive it yourself? Like Ms. Inlo taught you how to do, because I knew you would forget it? Okay? I'm trying to arm you. Alright, do this one with me real fast, okay? I'm trying to arm you with ways to solve for things that you don't necessarily need to memorize. If you memorize them, great. I don't really care if you memorize them. But if you don't know what the T1/2 formula is for the second order rate law, how do you use that formula to plug in to find the half-life formula? Clayton. I'm ready when you are.
1 over concentration K equals
This is a final.
over 2.
Over 2. Okay, I'm going to write that a little bit better. So 1 over A over 2. Why is that the half-life?
Because that's halfway through the
Right, this is A initial. So basically I'm saying that like once half of A initial has disappeared, that's our half-life. Time of half-life is when half of the concentration of the species has disappeared or been decayed. So that's our A final equals K, T, and T1 half is the one we're looking for, plus 1 over A initial. So this is how you plug in, and then you rearrange to solve for T, right? So when you solve for T, rearrange this for me so that you are solving for T. So you see this value here, that's going to go first, and then what? Subtract A initial and divided by K. I'm expecting you can rearrange algebraic variables, but this right here can be simplified to what? This first
2 over
thing, 2 over A, right? Because this is like copy dot plot where the 2 over A goes on like this. 1 over 1 times 2 over A. So then it's just 2 over A. Okay, so then 2 over A minus 1 over A over K is
1 over A over
1. So 2 minus 1 is 1. A stays with us. Over K. Okay, so continue to simplify.
K divided by A.
and then
Remember, this is K over 1 because it's in the numerator or the denominator. So then tell me.
K over A.
1 over Ka, or K initial concentration. This is the half-life formula. Okay, so if you had to derive it yourself, you definitely can. It takes a minute, but if you want to memorize it, it's on your own. You got to do it on your own time because it's not in the reference sheet at all. So that's on you. Then how would you solve for T1 half? On question 1, how would you solve for T1 half?
Plug in the K and the
Plug in the K value here, and
concentration.
we're at what concentration?
1
Say it again. 0.016 because it says calculate the concentration for initial concentration, which is 0.016. Okay, and then go ahead and calculate how much you guys got. I wanted you guys to lead these, but I'm going to help so I don't think we're going to get through Arrhenius today anyway, but I would like to, so we don't have to do it tomorrow. Tomorrow can be practice day. So T1 half is 1 over 0.0142 per molar seconds times, what's our A? 0.016. Okay, so then molar cancels and seconds come to the top. What's the T1 half? 4,401 seconds. Okay, I want you guys to look on the graph. That's concentration versus time. Estimate from that graph what the half-life is. Look at the graph for concentration versus time and estimate what the half-life time is. So tell me exactly what you're looking for. Tell me the definition of half-life again. Okay, so half the sample decomposing would be from initial of 0.016 to what? 0.008. Do you see where 0.008 crosses the graph? What time? Like 5,000 seconds? Yes? Okay, so you could actually estimate the half-life from a graph because you know the definition of half-life. The amount of time it takes for half the concentration to decay. So you're like, okay, half is 0.08, and 0.08 is like over here. It's actually a little less than 5,000. So I'd say like 49,000 seconds. This is definitely more accurate, but you can at least get in the ballpark if you had to guess from a graph or estimate from a graph. That takes 3 seconds, yes? But this one said calculate, so I wanted to show you how to calculate too. Okay, do we feel a bit better about gleaning information from this graph? Good thing we have 3 more questions to make sure we know what's going on. Yeah?
Why would you use that graph instead of the other ones?
Because the definition of half-life makes me focus more on the concentration, not the 1 over concentration or ln of the concentration, because the definition is like when half of the concentration disappears. And it's because everything can be graphed this way for half-life. Because the definition of half-life is whenever your concentration gets to half of its original. So every single time you figure out half-life from a graph, you should be using this graph. Cool? Okay, question 2, my people. You guys want to stand up? Question 2, let's go. Point, talk. Everybody tell me something here. So question A, everybody write down something for themselves. This is a good study aid. Data for this is collected in different ways. It's presented in 2 different ways below. Instantaneous rates for various concentrations and concentration at various times. Concentration versus time data is graph. What are the 3 methods by which you could determine the order? Tell me one.
Table logic.
Which table?
The instantaneous table.
Okay, usually you are not truly allowed to use instantaneous because that's not our initial rates, and then whenever we find out rate laws, it's for initial rate of reaction, but it does actually work on this one. Okay, next way.
Graphing.
Graphing how?
You look at the time
Uh-huh.
and the concentration.
So how are you graphing? Say it again?
You got the 3 different orders.
Okay, so you graph the orders in accordance to their axes, okay? So you're using instantaneous rate law to find the rate law. Okay, next.
Ugly algebra method.
So what data are you using for ugly algebra? Table logic stuff? Okay. What about, could you find average rate at any given time? Given this graph right here, can I speak right here? Given a graph like this, concentration versus time, I see this one's fairly linear, but if I wanted you to find the average rate at a given time, I know that sounds like it's instantaneous rate and it's already given, but like you actually can point out, I'm going to point out this value, draw a tangent, oops, that's a really bad tangent, but there's a tangent there, and then like maybe this one where it starts to flatten out some, find a tangent there. This would be concentration change over time, this would be concentration change over time. These 2 values would be rates. They would be average rates, or they would be kind of like initial rates. Those rates could be put into your table to do table logic a different way. So if you need to ever get specific rates or different rates, you can draw tangents, find your own rise of a run. And then you can also figure out the rate of formation of the product based off the concentration and time data, the product being in a nitrogen dioxide versus the consumption of nitrogen or dinitrogen pentoxide. I think that's all I got for you. Yeah, okay, question 2. What are 2 different methods by which you can determine the K?
The slope.
Okay, the slope of what?
The slope of the most linear.
Which was the most linear for y'all?
Found concentration versus time.
So what order is this?
First.
First order, and you found the slope. So what is the K value?
0.06.
Not negative. The negative itself does not describe the K. The negative describes the direction. So units though?
Per second.
Right, so 0.0006 per second because it's first order, so you should be able to find the units by thinking about the rate laws formulas. What are 2 different methods by which you could determine the half-life?
Half-life equation.
What is the half-life equation? Put on the board here. Scroll down a little bit for you. Half-life equation. No, it's you just gotta write it the other way. Okay. So T1/2 is equal to 0.693. Your head's kind of in the way, Josh. Over K, or 2 over K. I just remember the decimal 0.693. Another way. So that's a half-life equation. What's another way? The graph. What graph? Jack, tell me.
Amount of time.
Okay, tell me. Everybody, look at the graph and tell me the half-life. There's something there. So point 1. Don't draw on the board, Clayton.
There is
with the
no
pencil.
point this.
Okay,
There's
here.
no point.
Here, use this. We have these great.
There's no point.
markers.
It's just metal.
Okay, so what's the half-life time?
Seconds.
Go over to where the line touches the graph. Okay, so
1200 seconds.
right, 1150, 1200 seconds because it's a little lower, but you just basically need to look at the graph. All right, cool. Thanks, group. Question 3. Question 3. So I'm going to suggest you look at this again later because I think some of us are on that struggle bus a little bit here. Decomposition of hydrogen peroxide is studied at a particular temperature and experimental data on the right. What are two methods you could use to determine the rate law for this reaction for the data given? Tell me more about graphical.
You can use the concentration versus time to find the rate law. No, not the rate law.
Add to his thoughts. When he says graphical, what do you guys mean? Specific.
We'll see which one is most familiar.
By graphing it,
Using all three.
using all three relationships, okay? So whenever you say graphical on your test, you would not get points. You need to explain, okay? So that's why I say make sure you're talking about this versus time, this versus time, this versus time. On AP exam, they will not give you points in music graphical analysis. Keep going. Another way. Okay, so using that data there, because that's, well, no, not that data.
You can use the data from the graph.
You can find the rates from the graph.
How would you find the rates in the graph?
Draw a tangent line.
Draw tangent lines at like maybe 5 spots, find their rates, compare that to the concentration at that time. So concentration versus time. Do table algebra, algebra of the algebra. Okay. What is the rate law?
Rate equals K concentration of H2O to the first order.
Okay, first order. What are the 3 methods you could use to find the rate constant? Somebody else maybe? Rate constant K?
Slope of the graph.
Slope of which graph?
Concentration. Oh, no. LN.
The first order ln one. Good. Another way?
You can use the equation natural log of A initial equals negative KT plus natural log of A final.
And you could actually plug in data. You could say initial was 1, so ln of 1, and then final was 0.2, and that would be your ln of 0.2, and you could plug in the time it took, 1800 seconds, and solve for K. What would the units be? Actually, no, I got one more way.
The next question says there was only 2.
Next. What?
Look at CI.
What are the units of K?
The CI.
Okay, so what are the units of K?
Per second.
Per second, because it's constant. It's just the rate law or rate constant times concentration. Okay, so if you had to find the half-life, how would you do it?
Look at, alright, first you use the ln to over K.
Okay, so 2 1/2 is equal to ln of 2 over K, and plug in K. Another way? Well, that's the same thing as ln 2, same value.
You just look at the concentration versus time graph.
Okay, concentration versus time. What's the half-life, people?
800.
Say it again. About 800. So you're going from 1 to 0.5. That's about 800 seconds. I'm guessing it's seconds. Okay. Thank you, team. Go. You're good. All right. So if that was a little bit of a struggle, then please let me know. You want to use your tools and not work too hard, right? Work smarter, not harder. That kind of thing. Okay. Pull out your outline. That took us 30 minutes, guys. Ooh, okay. So let's pull out our outline. I'm gonna work through what I need to definitely do today, and if I have to save some tomorrow's gonna be a work day for you guys, but I might have to do a rainy tomorrow. All right, so quickly look at your outline and tell me what are elementary steps. I want to make sure this video is still going for Maggie, because the smart board's stupid today.